Hello my peeps. This Algebra Nation video will cover problem number 1 on the right side of page 128 and problem dos on the left side of page 129.
Or to do a factoring type of practice problem. So let's take a look. So we're given this information about Josie. It says that Josie works at a preschool. She needs to fill the sandboxes with new sand. Each sandbox is a different size but has the same depth. She wrote the following expression to help her determine how many cubic feet of sand that she needs to buy. And then it gives this expression right here, where it tells you that A, B, C, and D all represent different things, right? The A represents the area of the base of the large sandbox, B is the area of the base of the medium sandbox, C is the area of the base of the small sandbox, and D is the depth of the sandbox. Which of the following expressions is equivalent to that expression above? So what we take a look at is we say, okay, this is our expression that we're starting with, and then now what do we have to do to that? Well, if we kind of take a look at our answer choices, it looks like all of our answer choices are just a factored version of this expression right here. But which factored version is correct? Well, let's rewrite our expression that we need to factor and see if we can't figure that out. So we have 2AD plus 4BD plus CD. All right, so whenever we're trying to factor, what we're going to go through is term by term to see what all of those terms share. Okay, well, let's take a look. Do each one of these terms share a factor of 2? Yes, this one has a factor of 2. 2 goes into 4, so yes, the second term has a factor of 2. But then the last term has no coefficient. So if there's no coefficient, that means that 2 is not a factor of this last term. All right, let's see if they share any variables. All right, so in this first term, we see that this first term has an A and a D. The second term has a B and a D. All right, so just in these first two terms, we know that they share a D. And then in our last term, our third term, we see that it has a C and a D, so it also shares a D with the other two terms. All right, so then now we can see that in all three of these terms, there's a D that we can factor out. Well, how exactly do we do that? Well, what we're going to do is say that D is being factored out, and then what would that leave us with in parentheses? So what we're really doing is dividing each one of those terms, we're pulling out a D. So if we pull out this D from this first term, what are we left with? We're left with 2A. Because we got rid of the D, remember, we factored it out. It's almost like the opposite of distributing. We factored out that D. Well, now in the second term, if we factor out this D, all that we're left with is 4B. And then our last term, if we factor out the D, all that we are left with now is C. All right, so then now this is the factored form of the original expression that we had. All right, so we take a look at our answer choices. We see that the answer that we have right here looks like answer choice B. So that's what we would bubble in, and we got that one right. So if you have any questions, make sure to post on the wall, and I will see you guys in the next video.
Are you ready for a brain break? Whatever you do, I hope, I pray to the math gods above that you do not look like this clown on the EOC. Epic fail. And to think they gave this joker his own app on a phone and his own beverage. He should be denied for life. Hashtag Hater Nation.
Hey, how's it going, Algebra Nation? In this video, we're going to be looking for the greatest common factor given a certain expression, right? So what we're going to have to do is take a look at this expression right here, and then ask ourselves, for each one of these terms, right, there's three different terms, for each one of those terms, what do each one of those terms share? Okay, so that's what we're going to be asking ourselves. What do they share? Do they share any sort of coefficient that maybe would go into all of those terms? Do they share any variables that maybe go into all of those terms? Because what we're going to try to do is factor out all of those things that are in common with with each one of those terms in this expression. All right, so let's go the first way that I like to do this is if we break it up, let's look at our coefficients first. So what are coefficients? Coefficients are just the number that's out in front of our variables. Okay, so we have the coefficients of 55, 11, and 66. So what we have to do is ask ourselves, do those three coefficients share any factors? All right, well, 11, that's a prime number. So there's no other number. Like 2 doesn't go into 11, 3 doesn't go into 11, 4 doesn't go into 11. So 11 is a prime number. So 11 is the only other factor besides 1 of the number 11. So let's ask ourselves, does 11 go into 55? Well, if we want to take our calculator out, we can take 55 divided by 11 just to double check, and we see that yes, 11 does go into 55. All right, what about 66? Does 11 go into 66? We can do the exact same thing, and we see that yes, 11 does go into 66 as well. So then now, what does that tell me about the greatest common factor of this expression? Well, we know that 11 will go into all of my coefficients, so that means that 11 is part of my greatest common factor, because I know that I can take out an 11 from each one of my terms. All right? Then now we have to ask ourselves about each one of the variables individually. So let's look at s first. So in this first term, I have s to the fourth. In the second term, I have s to the second. In the third term, I have s to the eighth. So now what I ask myself is, which one of those numbers is the smallest? Because remember, we're trying to look for the greatest common factor. So what factor of s raised to what power, is shared by all three of the terms? Well, we have s to the fourth, s to the second is lower than s to the fourth, and s to the second is lower than s to the eighth as well. So s to the second is the smallest that all three of those terms share. So that is going to be able to factor out as well, s to the second power. Then we're going to treat this exactly the same way for the other two variables. So here we have d to the seventh, d to the ninth, and d squared. Okay, I'm going to let you think about that for a second. Which one of them is the lowest power of d? Which one of them is d to the lowest power, or has the lowest exponent on d? Well, we know that we have d to the seventh, d to the ninth, and d to the second, or d squared. So I see that d to the second is the lowest one. So that means that d squared is shared by each one of those three terms. So we have this term that has a d to the second, this term that has a d to the second, and this term that has a d to the second. All right, now let's look at our a's. We have a to the sixth, a to the fourth, and a to the eighth. Okay, well, again, I'm going to ask myself, which one of those is the lowest exponent of a? Well, a to the fourth, because 4 is lower than 6 or 8. So I know that at least there is an a to the fourth in each one of my three terms. There is at least an a to the fourth in each one of my three terms. So I know that I can factor that out as well. All right, so this is just asking for the greatest common factor. So we just broke it up into coefficients first. We found out what the greatest common factor of all the coefficients were. And then we took each one of the variables individually. All right, so then I figured out that this was my greatest common factor.